Let us understand about geometric progression. Let us consider the following sequences: 2, 4, 8, 16, and similarly 1 by 9, minus 1 by 27, 1 by 81, minus 1 by 243, and so on. We have two sequences. In sequence 1, we have a1 equals to 2, a2 by a1 equals to 4 by 2, which is also equals to 2, a3 by a2 equals to 8 by 4, which also gives 2, and so on. Similarly, in the sequence 2, we observe that a1 equals to 1 by 9, a2 by a1 equals to minus 1 by 3, a3 by a2 equals to minus 1 by 3, and so on. We observe that in each case, every term except the first term bears a constant ratio to the term immediately preceding it. Such sequences are called geometric sequences or geometric progressions, abbreviated as GP. A sequence A1, A2, A3, and so on till An is called a geometric progression if each term is a non-zero term and ak plus 1 by ak equals to r, which is a constant for all k greater than 1. By letting a1 equals to a, we obtain a geometric progression a, ar square, ar cube, and so on, where a is called the first term and r is called the common ratio of the GP. Let us understand general term of geometric progression. Let us consider a GP with first non-zero term a and common ratio r. Now we will write few terms of it. Thus a1 equals to a, that is equals to a r to the power 1 minus 1. a2 equals to ar, that is equals to a2 equals to ar, that is equals to a r to the power 2 minus 1. Similarly, a3 equals to a r to the power 2, which is equals to a r to the power 3 minus 1, and so on. The pattern suggests that the nth term of the GP is given by an equals to a r to the power n minus 1. Thus, a GP can be written as a, ar square, and so on till a r to the power n minus 1. This is called a finite GP if n is a finite, and an infinite GP if n tends to infinity. And the series can be written as a plus ar square, and similarly until a r to the power n minus 1. This is called a finite geometric series, or we can write it as a plus ar square plus ar cube, and so on a r to the power n minus 1, and also for infinite terms. This is called infinite geometric series. Sum of the n terms of geometric series. Let the first term of GP be a and the common ratio be r. Now Sn can be written as a plus ar square, and so on. Let us call this equation number 1. When r equals to 1, we note that Sn equals to n into a. Now when r is not equal to 1, we multiply equation number 1 by r and get r into Sn equals to ar plus ar square plus ar cube, and so on. We call this equation number 2. Now subtracting equation 2 from equation 1, we have Sn into 1 minus r equals to 1 minus r to the power n, or we can write it as Sn equals to 1 minus r to the power n divided by 1 minus r. Geometric mean. The geometric mean between two numbers a and b is given by root of ab. Given any two numbers a and b, we can insert n numbers g1, g2, g3 and so on till gn, such that b equals to a into r to the power n plus 1. Or we can write it as r equals to b by a to the power 1 by n plus 1, or gn equals to a into b by a to the power n by n plus 1.